Hello students, in this video we are going to learn that how we can balance a chemical equation. This topic is from class 10. Now, first of all, we need to know that what is a chemical equation. Now, we know that there are two type of changes. One is physical change and another one is chemical change. In physical change, there is no chemical reaction involved, but in chemical change it is always backed by a chemical reaction. Now, what is a chemical reaction or a chemical change? Any change in which a new substance is formed and which is irreversible is called a chemical change. So we know that the chemical change is backed by a chemical reaction. Now, the symbolic representation of a chemical reaction is called a chemical equation. Now, in this chemical equation, we find that there is an arrow. The left side of the arrow, we represent the reactants of the chemical reaction. And in the right side, we mention the products of the chemical reactions. If there are more than one reactant and more than one product, we use the plus symbol. Okay, so reactant A plus reactant B gives product C plus product D. This is the format of a chemical equation. So here you can see that one chemical equation is written that sodium hydroxide plus hydrochloric acid gives sodium chloride plus water. Now, here comes a question that why we need to balance a chemical equation. For example, if I write an equation that sodium plus chlorine gives sodium chloride, right? This is a chemical equation, but it is not the balanced one. So, why we need to balance a chemical equation? So here comes a law which is called the law of conservation of mass. According to this law, mass cannot be created and neither it can be destroyed. It only can be transformed from one form to another. So every chemical reaction follows the law of conservation of mass. So according to this, we need to make the number of atoms or elements in the reactant side and product side equal, right? So we need to balance a chemical reaction to express its accuracy and to make it follow the law of conservation of mass. Now, how we can balance a chemical equation? See, there is not a fixed method or fixed procedure by which we can balance a chemical equation. It is always hit and trial method. That means we can try and we can continuously checking whether the reaction is balanced or not, and finally we can reach to a final balanced equation by trying and hitting and trying method. Let's try to balance this particular equation. The chemical reaction is that when iron reacts with water, we get iron oxide and hydrogen gas. This is a chemical reaction and the symbolic form is called chemical equation. So iron plus water gives iron oxide plus hydrogen gas. Now, first of all, what we will do, we will draw these kind of boxes around the formula of all the reactants and all the products. Why so? Because sometimes some student make the numerical changes inside the formula, which makes the chemical reaction incorrect. So we will not change any number inside these boxes. You can see here H2O. So we will not change this 2, this 3, 4 and this 2. These digit will not be changes, because if you change those, the formula will be wrong. So this is the first step. In second step, we will find out that the number with the atom with the maximum number, and first of all we will list all the atoms including their number in the left hand side and right hand side. So here we can see iron, left hand side the number of iron is 1, in right hand side the number of iron is 3. Hydrogen atom, left hand side the number of hydrogen is 2, in right hand side also it's 2. And oxygen, left hand side it's 1 and right hand side it's 4. So this is a step 2. We will account all the atoms left and right side and we will compare them. Now see, we need to make these numbers equal. So from which atom we have to start? So there is not any hard and fast rule, but if we start with the atom with maximum number, it may be easy for us. So we can see here the oxygen atom has the maximum number, which is 4. So it is convenient to start balancing the compound with maximum number of atoms. This is step 3. Again, I'm saying that we do not need to keep these steps in our mind. It is just for understanding purpose. So what we can do, we can make the number of oxygen atom, or we can multiply the number of oxygen atom by 4 to make it equal, right? So what I do, I write 4 here. Okay, so now oxygen atom in the right hand side and left hand side are equal. But when I make the oxygen number of oxygen atom equal, the number of hydrogen atom is changed by default. So I have to mention the new number of hydrogen atom in this table. Now the hydrogen in the left side is 8, right? So now we will try to balance any of the remaining 2 atoms. Let's make the hydrogen equal. Here we can see that if we multiply this by 4, it will come to 8. So I write 4 here. Now hydrogen is also balanced. And now let's balance the remaining atom, which is iron. So simply I will multiply the number of iron with 3. So this equation is now balanced. You can check number of atoms of iron, hydrogen and oxygen in the left hand side and right hand side. Iron is 3, 3. Hydrogen is 4 into 2, 8. 4 into 2, 8. Oxygen is 4. Oxygen is 4. So this equation is balanced. Okay, so these are the steps. In step 3, what we did, we balanced the maximum number of atoms. Then we balanced the remaining atoms like hydrogen and iron. And in step 5, we will examine whether the equation is balanced. And finally, we will check the balanced equation. Now, for add-on, what we can do, we can also mention the physical states of these reactants and products. Now, if a reactant or product is gaseous, we can use a symbol small g. If it's liquid, we can use small l. If it's solid, we can use small s in the bracket. If it is in a solution phase and solution prepared in water, we can use the symbol AQ. AQ means aqueous. So here, iron. Iron is solid. So we can mention here solid. Water is liquid. Iron oxide is solid. And hydrogen is gas. So this is the final balanced equation. Let's try with some different example. Suppose methane reacts with oxygen and prepares carbon dioxide and water. So step 1 is to prepare a boxes around the reactant and product. Now we will not make any changes inside these boxes. Step 2, we will count all the atoms present left and right hand side, including their numbers. So in left hand side, the carbon atom is 1, hydrogen is 4, oxygen is 2. In right hand side, the carbon atom is 1, hydrogen is 2, and oxygen is 3. Now we will try to balance atom with maximum number. So let's balance the hydrogen first. So to balance the hydrogen, what we can do, we can multiply the number of hydrogen atom with 2 in the right hand side. So it becomes 4. So hydrogen is balanced. Now by default, the number of oxygen atom in the right hand side became 4. So I write the new number of oxygen atom, which is 4. Now you can see that the carbon is already balanced, and oxygen, we can multiply number of oxygen by 2 to make it equal. Now this equation is chemically balanced. What we can mention? We can mention their physical state. Now mentioning physical state is not mandatory. So this is gas, and this is liquid. I hope you have understand the procedure of balancing very well. Again, I'm saying that these steps are just for the practice purpose. Again, whenever you balance, it is always hit and trial method. So I'm giving you one equation for the homework. Try to balance this equation. The equation is when we burn magnesium ribbon, it gives magnesium oxide. Try to balance this equation. Thank you.